So right here we got a system of equations that we want to solve. You can see we already have all our variables on the left. We've got x1, x2, x3. They're all lined up in the same order. That means we are ready to create our augmented matrix to solve this one with row reduction. So for our augmented matrix, what we're going to do, we're just going to take the coefficients of each of these, stick it in one row for each of the equations. We'll draw a little line for the equal sign. So for that first row, we've got x1. It's got a secret 1 coefficient here. x2 is 1. x3 has a 2 coefficient. For our equal sign, we're going to draw this little vertical line. We put our constant term is 8 on the right-hand side. Do that here for our next two rows. We've got -1, -2, 3, and 1. 3, -7, 4, and 10. Boom. Beautiful. So the goal is to reduce this down to row-reduced echelon form so we can rewrite these, get our x1, x2, x3 values, yeah. So what we want to do is we're going to start with the first column. So our 1, -1, 3 here, and our goal is to make this into 1, 0, 0. So it looks like that first column of like the identity matrix. And then once we do this, we'll move on to the second column, make it look like a 0, 1, 0, and so on until it all looks like a beautiful little identity matrix. So we already nailed the first one. Look at that. Good job, everybody. Nailed it. So now we'll look at making this one a 0. So usually what we want to do for these ones is we want to use this form of a row operation where we're going to take row 2 and then we're going to replace it with row 2 and then plus or minus a multiple of another row. So what's common is since we have a 1 here, that makes it real easy to scale. So since this is a -1, if we add row 1 to row 2, then what that'll do is this first entry will be -1 plus 1, and we'll get a nice little 0 here, just like we're looking for in our first column. So for this one, let's let's write these out and do the full computation. And for the rest of them, I'm going to be lazy. We'll just write the answer, do it in our head real quick. But for this one, what we want to do is, so we have like, we're doing row 2 plus row 1, right? So here is row 2. This is how I'd recommend if you want to write out all the steps and do it. So we've got row 2, and then we just have a single row 1 that we're adding. So we'll keep that as just 1, 1, 2, 8. And then our new row 2 is going to be the sum of these. So we'll just add straight down here. And so it's like you're doing 4 little addition problems. So we've got -1 plus 1 is 0. Perfect. -2 plus 1 is -1. 3 plus 2 is 5. 1 plus 8 is 9. And so this guy is going to be our brand new row 2. So, so after performing this operation, what we'll get for our next matrix, we're going to leave rows 1 and 3 the same. Fill these guys out. 3, -7, 4. They're itching to get changed too. We'll do that next. But now our new row 2, this is going to be 0, -1, 5, and 9. Beautiful. So now, right, we're starting to look more and more like this 1, 0, 0 thing, right? We got a 1, we got a 0. Last thing we got to do is make this 3 into a 0. What we're going to do is we're going to take row 3 now, because that's what has to be changed. So we want to replace row 3. And we're going to replace that with row 3. And we want to combine this with row 1 so that this 3 becomes a 0. So since there's already a 3 here, we want to somehow be like subtracting 3 and do 3 minus 3. So since there's a 1 in this entry, what we'll want to do is -3 row 1. So that for this first computation, it'll be 3 minus 3 times 1 is 0. And then we'll do, we'll have to follow that with the 1 and the -7, the 4 and the 2, and so on. So if we do that one real quick in our heads, I'm going to come horizontally here to save virtual whiteboard space. Save all those virtual trees out there, everybody. Don't forget. Don't forget about the virtual trees. So we're going to leave row 1 and row 2 the same. 1, 1, 2, 8. 0, -1, 5, 9. And then this one, each computation is going to be this entry minus 3 times the entry in row 1. So for this first computation, we've got 3 minus 3 times 1 gives us 0. Hooray. Look, we did it. We did it. Yay. Now let's go to the next one. So we've got minus 7 minus 3 times 1 gives us a negative 10. 4 minus 3 times 2. 3 times 2 is 6. 4 minus 6 gives us a negative 2. This one here, we've got 10 minus 3 times 8. Whoa! This one's getting out of my wheelhouse a little bit. 3 times 8, that gives us, what, 24? So we've got 10 minus 24 gives us a negative 14. Okay. All right, so now we are down to this matrix after finishing up this first column. I just recopied this guy down here, no changes. So I just wanted to get it back in this kind of leftmost spot. So now we finished the first goal. So what the hell do we do now? Well, our second goal is to repeat this with the second column. But now, right, in our row-reduced echelon form, remember the idea is we're trying to get these pivots so that they're in this sort of downward staircase motion. So since we got a 1, 0, 0 here, we want to make the second column look like the second column of the identity matrix if possible. So we want to get a 0, 1, 0 here. So now that we know we're looking to do a 0, 1, 0 here in the second column, now that we have our new goal, we always want to start with the 1 whenever we go to a new column. So we finished column 1, now we're going to column 2 to do 0, 1, 0. So we want to start with the 1 first, using the row multiplication operation. So what the hell does that mean? So there's an operation we haven't used yet, which is you can take a row and multiply it by a constant. You usually don't want to multiply it by 0, then you just kill everything off, you lose all the information, devastated. So you can multiply it by a non-zero constant, and that's what we usually use here to turn our entry that we want into a 1. So all we'll do here for row 2 is we're just going to replace it with minus 1 times row 2. So that we flip the signs on all these, that's going to turn this minus 1 into a beautiful plus 1. So doing nothing to row 1 and row 3 here. But each of these, we're going to flip the sign. 0 stays 0. We get 1, minus 5, and minus 9. Okay. Hooray, we can feel accomplished. Check this off our list. So now our next step is to make the entries above and below it a 0. So we now want to make this 1 into a 0. We can start there. We can also do the negative 10. Doesn't make too much of a difference. And so the key here is that what we'll want to do, we want to use this 1 that we just made. So kind of like we did in that first goal, we are going to take row 1 and replace it with row 1 plus or minus some multiple of row 2. We're like using row 2 now as our utility row to subtract from the others. So what I want to do here, since we have 1 and 1 matched up, if we just subtract them, that should do a nice job of canceling out these, and then we'll see what happens with the rest. Okay, so if we do this, our row 1 now is finally going to change. He's jealous of the other rows. So we'll do 1 minus 0 is 1. 1 minus 1 is 0. 2 minus negative 5 is 7. And 8 minus negative 9, we will then do like 8 plus 9. What is that? That's 17. Okay, copy down the rest of it. We can just do one row at a time. Once you get comfortable, you can do a couple operations in a row as long as they don't interfere with each other. We'll just do one at a time for this. So we've got this here. So let's come down here. We've got that 0 checked off. Oh no, my goal. Okay. And so now the last thing we need to do is fix this minus 10 here. If we can make that into a 0, then we'll be done with this second goal. We'll be close to finishing. And so this is where we're again going to do a similar operation here. So we're going to do row 3, and we want to like add or subtract some multiple of another row. And it's really important here that we use row 2. A mistake that a lot of students make is if you're back at this step, some students, what they try to do is they try to do row 3, like say plus 10 row 1. But that is going to cause you a lot of problems because that's going to make this entry not a 0 anymore. Feel free to try it out if you're interested so you can see what not to do. But what we're going to do is we're just going to combine row 3 with row 2 to avoid that. So since we've got our minus 10 and a 1 here, we just want to do plus 10 times row 1 and that will give us what we're looking for. Okay, so let's copy down our other rows. Those don't change. Wrong color. Awkward. Okay, so rows 1 and 2 don't change. Lucky you, you get to watch me write down numbers. Okay, and so then in this row 3, now what we're going to be doing is we're going to take row 3 plus 10. Who wrote that 1? That is so embarrassing. Oh my god. And I'm erasing everything all over the place. Get me out of here. Okay, so we are not doing that. We're not doing that either. So we are doing row 3 plus 10, row 2. All right, sorry everybody. Please don't leave. Okay, so we're doing plus 10, row 2. So we got 0 plus 0, leaves us with a 0. We've got minus 10 plus 1 times 10 is going to give us a 0, like we cooked up. Beautiful, drew up the play. Look at that, nailed it. Now we got to do these other awkward ones. So we've got minus 10 plus 10 times negative 5. So we've got I think I misspoke again. Oh my goodness. So we've got negative 2 plus 10 times negative 5. So negative 2 minus 50 gives us a negative 52. And feel free to write out each row entry so you don't make all these dumb mistakes like me. And then this one, we got something crazy here. We want to do for this last entry, we're doing negative 14 plus 10 times negative 9. This one's hard. I'm going to write it. So we've got negative 14 minus 90. So that's going to give us what? A negative 104, I think. Okay. Looks like a terrible number, right? Who wants to see 104 in their math problem? Not me. But we've got this 52 here. Those are divisible, so this should get cleaned up in our next step. Okay. Anyways, if we scroll back up, we can see we have completed goal number 2. Ye freaking ha, am I right? So we've got 0, 1, 0. So that second column's looking beautiful. Okay. So now we just have one more column to do. We kind of need to repeat this with our last column, and then we'll be happy. So let's come down here. And so for our last goal, that'll get us to our final step. We want to make now the third column. We want to make it look like our beautiful little identity columns. But since we've already got these, we're looking for a 1 in the bottom right spot. Yeah? So we want to make the third column now a 0, 0, 1. Then we'll be able to do our back substitution and solve from there. Okay, so like we did before, we have our algorithm, right, which is our first step is to make this 1 a reality. So we're going to look at our negative 52 here. And instead of combining that with something up here, right, again, this would be a great thing to try on your own and see why it doesn't work. But if you tried to do this minus something times row 1 to cancel that out, well, you've got a 1 here, that's going to mess this up. Don't do that. What you want to do instead is just take your row 3 and divide it by that constant, and that's always going to give you a 1 here. So we're just going to take row 3, and we're going to replace that with negative 1 over 52 times row 3. So division, I like to multiply by reciprocals, don't tell anybody. Okay, so if we do that here, our first ones are not going to change. And then we're going to divide this out. So we've got a 0. To multiply this by this, you just stay 0. So that's beautiful. When we do negative 52 divided by negative 52, we get a beautiful little 1 here. Negative 104 divided by negative 52 is going to give us a positive 2. So that's always a good sign, right? You can definitely get fraction answers, but whole numbers usually means you did something right. Okay, so now we've just got 2 more things to do, and then we're almost done. Thank God, I'm over it at this point, to be honest. So now let's get rid of this negative 5, right? We got this guy done. So now we make these 2 zeros, and then we can finally go home to our families. Okay. So what we want to do here is, like we did before, the key for this, we're replacing row 2. What we want to do with it is we want to add or subtract a multiple of row 3, right? The 7 and the negative 5 don't line up, but even if they did, if you did row 2 and row 1 combined, you're going to mess up the zeros. Don't do that. What we want to do is use that 1 we just created. So we're going to do row 2 becomes row 2. We want to add some multiple or subtract some multiple of row 3, so these cancel. Since this is negative and this is positive, we'll just do plus. We got to scale this guy by 5, and then they'll combine nicely. So we'll do row 2 plus 5 row 3. and that should work for us. Let's see what we get. Okay, so we're not changing row 1. We're going to change row 2. So in each of these steps, we're doing row 2 plus 5 times the row 3 entry. So you technically even, it's sort of supposed to happen with the zeros too. We're doing this operation. But we do 0 plus 5 times 0. That's 0 still, hooray. We do 1 plus 5 times 0. That's 1 still, hooray. Right? That's really the key to why we work left to right with these identity columns and do the operations we do, so you don't mess with the stuff to the left. Anyways, I'll shut up. And so here we do minus 5 plus 5 times 1. That gives us 0. We do 9 plus 5 times 2. Right? Wait, this 9 is negative, isn't it? Oh, he thought he could sneak past me. I would like to formally apologize to everyone watching. These guys are negatives. That's a negative. Oh no. So we're going to do... negative 9 then plus 5 times 2. So that is negative 9 plus 10 is 1. Oh, thank God. I thought I made some worse mistake. Okay. I'm going to leave this in so you all can see, you know, even geniuses like me make mistakes. So don't be discouraged. Follow your dreams, you know. So anyways, that's our new row 2. So we'll copy down our row 3. And we are so close. This is looking beautiful. We can already kind of see what the solutions are. We just got to fix this last one. So check that guy off. So for our last thing, we just need to make the 7 into a 0, and then we can all go home and hug our children. So what we want to do here, just like last time, we're going to take our row 1, and we are going to replace it by doing row 1 plus or minus a multiple of row 3 here. So here we've got a 7 and a 1, so we need to subtract 7 of these row 3 guys, and that should do the trick. So let's do that, and that'll bring us home. So we're not going to change rows 1 and, what am I saying? We're not going to change rows 2 and 3. So I'm just going to go ahead and write those, get the easy part done first, give me motivation. All right, sweet. So then we're doing row 1 minus 7, row 3. So we've got 1 minus 7 times 0 is 1. 0 minus 7 times 0 is 0. 7 minus 7 times 1 is 0. Nailed it. And then, now we've got 17 minus 2 times, minus 7 times 2. Getting a little crazy here. So that's what, we got 17 minus 14 gives us a positive 3. Okay, so, hooray, we finished our goal. Let me go back up and check it off, or I will be upset. Hooray. So we finished our goal. So we've got this matrix here, and now we can finally get our solution, yeah? So all we got to do here is, this is in our row-reduced echelon form, yay! And so then to get our solution, all we need to do is see if we do back substitution or what we got, but if we write out each of these equations, you'll see it's a really boring equation, which is the best kind. It'll just say x1 is equal to 3, because you got zeros on the x2 and x3. You got x2 is 1. And you got x3 is 2. So this is our solution. We got a nice consistent system with a unique solution here. You've got 3, 2, or 3, 1, 2 in terms of our x1, x2, x3. You could throw it in a little ordered triple if you're feeling fancy.